this video, we will study quantities that are not evaluated continuously over any period of time, but at the fixed periods of time. For example, the GDP. The GDP of a country is evaluated quarterly. So this means every 3 months, and you have, say, the GDP, the first, then 3 months later you have another figure, 3 months later you have another figure, and so on. So what we have is an equation on these quantities, and what we want to get is a formula or expression for these quantities. Let's work out two very simple examples. One is the doubling sequence that you can read about regarding the invention of chess. Here you start with the number 1, and the next number is twice this one. So 2 times 1 is 2, then the next one is equals to 4, then 8, and so on. So one number, 2 times 1, 2 times 2 times 1, then 2 times 2 times 2 times 1, or a number 2, 2 squared, 2 cubed, and that's the sequence. So this formula at any time t is equals 2 to the t. And the equation here is any number is obtained as twice the previous number. So since we have the solution first, we have built the solution, we know the equation. This is what we have done, but what we want to do is precisely the opposite. Let's consider another, which is the Fibonacci sequence. This sequence starts with the first two numbers are equals to 1, then the next one is the addition of these two, 1 plus 1 is equals to 2. Then the third one is the addition of the two previous, which is the 1 here, plus 2 here is equals to 3. Then the next one will be this here, 2, plus this number here, 3 equals to 5. Then 8, and so on. So what is the equation here? The equation is any number is the addition of the previous t minus 1 plus 2 before t minus 2. This is the equation. Now what we want is there is a formula for t, and this is what we are going to study. Difference equations many times are called also recurrence equation or recurrence relations, and we'll do the following steps to solve a difference equations. We'll first study what is called homogeneous, then we'll come to the case of the particular solution, and finally we get the general solution with the initial conditions explained somewhere else. So let's start with the homogeneous equations. So a homogeneous difference equations is an equation like this one we have here, which involves some terms on yt minus 7 times the previous plus 10 times 2 periods before equals to 0. Homogeneous is because it's equals to 0. To solve this equation, you need to know the following. First of all, what is the degree of the equation? The degree of the equation is the biggest subindex minus the smallest one. In this case, we have the biggest subindex is t, corresponding to this term, minus the smallest is this one here, t minus 2. So that's t minus t plus 2 is equals to 2. You need 2 steps to go from the biggest subindex to the smallest. Once you have the degree from the difference equation, you have to construct a polynomial equation, and has to be a polynomial equation of degree 2. And how do you do? Okay, so the biggest index corresponds to lambda raised to the degree. One subindex less corresponds to lambda raised to 1 in power less. 2 minus 1 here is 1. and another index corresponds to another lambda raised to 0, but that's 1. So let's change color here to see it better. And what we have is this corresponds to the same as here. So lambda squared minus 7 t minus 1 corresponds to lambda plus 10 times, and t minus 1 corresponds, t minus 2 corresponds to 1, which we don't write. So we have that equation. And what now we solve this equation as a quadratic equation. Lambda equals plus minus 49 minus 40 divided by 2 times 1, and this is 7 plus minus 3 divided by 2. 7 and 3 is 10 halves of 5, and 7 minus 3 is 4 half equals to 2. Okay, so then this number generates one solution of the equation, which is 5 raised to t. And this number generates another solution, 2 to the t. So we have from the equation yt minus 7 yt minus 1 plus 10 times yt minus 2 equals to 0. We have 2 degree 2, so 2 basic solutions, which are 5 to the t and 2 to the t. And how is the general solution of this? The solution of this equation will be yt equals a constant times the first basic solution plus another constant times the second basic solution, where C1 and C2 are numbers that if you have initial conditions, you can compute them. Just one remark here, what happens in a case where we have repeated solutions. If, for example, our equation were something like yt minus 4 times yt minus 1 plus 4 times yt minus 2 equals to 0, or lambda squared minus 4 lambda plus 4 equals to 0. Here, lambda is equals 4 plus minus square root of b squared minus 4ac divided by 2. So this is 4 plus minus 0 divided by 2, and we have 4 over 2 and 4 over 2 also. This will give a basic solution 2 to the t. Here, if we have as a basic solution 2 to the t, you can see both are the same. So actually what we have is it's easy to check that the solution t times 2 to the t is also a solution of this equation. And now let's go for the non-homogeneous part.